So today we're continuing on with 2.5 and we're looking at example 2.1. This is number 4. We already covered 1 through 3. And this was an important one because when I went to do your solution set, I know that there was a problem in this homework that was not very intuitive, and it comes from this problem will help you out. So anyways, when I first looked at this, I said, well, this has got an X and a Y, but this here's got an X and X prime, so it's not like you can take those out. Well, okay, well, these two have Y's. So I said, well, you could take the Y out and then um you would have X plus Z, right? And you would still have this term here, X prime Z. Well, that doesn't get you very far. So I said, well, let's forget that. And so I said, okay, well, that's not what I want to do. So what do I think I want to do? And so I said, well, there's a Z here and there's a Z here. So maybe I could just have the XY and then say plus Z times X plus Y. Now this is the distributive property or reverse distributive. But then I was also stuck. So I says, okay, well, that's not great. So what is it that I am supposed to do in this problem? So they do something that's a little not intuitive to help you break this down. So what they do is they leave the X, well, their first way, they do this two ways. So there you got XY, and you've got your X prime Z, which is the second term. And then your third term is YZ. And what they do is they multiply this by X plus X prime. And the reason that you can do that is because X plus X prime is equal to 1. And if you come up here, you can multiply anything by 1 and still have it be itself. So where does this lead us, though? So this leads us to, we still have our xy plus our x prime z, but now we can distribute this, right? Consider this to be distributive, which is here, right? And this is basically our x from over here. This is what you're distributing. So we have yz times the first term, which is x, plus yz times x prime. So once you have done that, then you can move things around a little better in here. Okay, so let's see. Well, what can you do? So we could group these differently if we change by the commutative property. Say we move these around, you have xy plus the commutative property allows you to change those around too. You like to have them in going up in the alphabet. So then you would have x prime z, and then you would have plus x prime y z. Okay, so now that you have this, you have, let me just get this right. So, I did this was a little not intuitive too. I said that, well, you can rewrite this xy as xy times 1, once again, up here, right? So then, plus if this is an x, y, z, this term, you can end up pulling out your x and your y, and you still have this 1 here. So this is reverse distributive times z, right? And I'm trying to remember why I did this. Let me pause this for a second. Maybe that's not what I wanted to do. Okay, I remember why I did this now. Okay, so we can just follow this down. So now we have, let's just change colors so we can see what we're doing here a little better. So we'll go to blue. So now you have 1 plus z here. So if you come over up to here, right, that this is an or, right? So if you have a z or a 1, that's always going to come out to 1. So you could consider this x and 1, okay? And then with this, you come up here. Let me just erase something because we're making a big mess. And so you know that anything times 1 is itself. So then this is just x, y. Okay, so let's go over to the other side of the equation. I'll just do it in different. So this is now, so that took care of this side, okay? So now what can we do over here? Well, we have an x prime and a z that we could take out. So we have x prime z. Now this is reverse of the distributive. And so what's left, once again, just like we did over here, right? We can say this is times 1 from our rules. So when we take the x and the z out, this becomes 1 plus y. Okay, so this is the exact same thing as the other side, which x, if you have a term ORed with a 1, it's always going to be 1. So this is x prime z and 1. And we know that anything ANDed with 1, which is back over here, just gives you the term. So that's x prime z. Okay, and we still have an OR in the middle here. So this is a plus. And that's where they end up with that problem. That's the least amount of literals.